Hello everyone. In today's video, we are going to discuss about FindS algorithm. Introduction. This presentation will introduce the FindS algorithm. It is a machine learning algorithm used for supervised learning. In this presentation, we will cover the implementation, advantages and disadvantages of the algorithm. In order to understand FindS algorithm, you need to have a basic idea of the following concepts as well: concept learning, general hypothesis, and specific hypothesis. Concept learning. Let's try to understand concept learning with a real life example. Most of human learning is based on past instances or experiences. For example, we are able to identify any type of vehicle based on a certain set of features like makers, model, etc. that are defined over a large set of features. These special features differentiate the set of cars, trucks, etc. from the larger set of vehicles. These features that define the set of cars, trucks, etc. are known as concepts. Similar to this, machines can also learn from concepts to identify whether an object belongs to a specific category or not. Any algorithm that supports concept learning requires the following: training data, target concept, and actual data objects. General hypothesis. Hypothesis in general is an explanation for something. The general hypothesis basically states the general relationship between the major variables. For example, a general hypothesis for ordering food would be, I want a burger. Specific hypothesis. The specific hypothesis fills in all the important details about the variables given in the general hypothesis. The more specific details into the example given would be, I want a cheeseburger with a chicken pepperoni filling with a lot of lettuce. Now, let's talk about the FindS algorithm in machine learning. The FindS algorithm follows the steps written below. Initialize H to the most specific hypothesis. The FindS algorithm only considers the positive examples and eliminates negative examples. For each positive example, the algorithm checks for each attribute in the example. If the attribute value is the same as the hypothesis value, the algorithm moves on without any changes. But if the attribute value is different than the hypothesis value, the algorithm changes it to question mark. How does it work? The process starts with initializing H with the most specific hypothesis. Generally, it is the first positive example in the dataset. We check for each positive example. If the example is negative, we will move on to the next example. But if it is a positive example, we will consider it for the next step. We will check if each attribute in the example is equal to the hypothesis value. If the value matches, then no changes are made. If the value does not match, the value is changed to question mark. We do this until we reach the last positive example in the dataset. Implementation. To understand the implementation, let us try to implement it to a smaller dataset with a bunch of examples to decide if a person wants to go for a walk. The concept of this particular problem will be on what days does a person likes to go on a walk. Looking at the dataset, we have 6 attributes and a final attribute that defines the positive or negative example. In this case, yes is a positive example, which means the person will go for a walk, and no is a negative example, which means the person will not go for a walk. So now the general hypothesis is, this is our general hypothesis, and now we will consider each example one by one. Only the positive examples will be considered. The general hypothesis has all the attributes value of the first example. Now let us match it with the third example, that is the next positive example in the given data set. Morning matches with morning, so no changes are made. Sunny matches with sunny, so no changes are made. Warm does not match with moderate, so it is replaced with a question mark. Yes matches with yes, so no change. Mild does not match with normal, so it is replaced with a question mark. And strong does not match with normal, so it is again replaced with a question mark. This is the hypothesis value obtained. Now let us consider the last example in the given data set. Morning does not match with evening, so it is replaced with a question mark. Sunny is same as sunny, so no change. Moderate does not match with cold, so it is replaced with a question mark. Yes and yes match, so no change. Normal is not same as high, so it is replaced with a question mark. Normal does not match with strong, so it is again replaced with a question mark. So this is the final hypothesis value obtained. We replaced all the different values in the general hypothesis to get a resultant hypothesis. Now that we know how the FINDESS algorithm works, let us take a look at an implementation using Python. This is the Python code that is used to implement the FINDESS algorithm. Before implementing this code, make sure Pandas and NumPy modules are installed in your computer. The data is given in the form of a CSV file. So this part of the code is used to read the CSV file, and this part of the code is used to make an array from all the attribute values that are obtained from the data. Segregating the target that has positive and negative examples. So the positive examples are segregated from the negative examples using this part of the code. And this part of the code is used to implement the FINDESS algorithm, and the final hypothesis value is printed. The table discussed below is given as an input in the form of CSV file, and this is the output obtained. The final hypothesis value obtained using the code matches with the sought example. Advantages. The FINDESS algorithm is easy to understand and implement. It is also computationally efficient and requires less memory. It is suitable for small data sets and can handle noisy data. Limitations. There is no way to determine if the hypothesis is consistent throughout the data. Inconsistent training sets can actually mislead the FINDESS algorithm, since it ignores the negative examples. FINDESS algorithm does not provide a backtracking technique to determine the best possible changes that could be done to improve the resulting hypothesis. In conclusion, the FINDESS algorithm is a simple and effective machine learning algorithm used for supervised learning. It has several applications in various fields. However, it may not work well with large and complex datasets. Overall, it is a useful algorithm to have in your machine learning toolbox. Thank you.